Welcome to The Explainer. Today, we're diving into a great story from Under the Microscope, the flagship podcast from the Science Talk. We're going to follow the journey of materials engineer Dr. Drew Evans and what his path from the lab bench to the production line can teach all of us about what real-world innovation is all about.
This right here, this single idea, is really the engine behind Dr. Evans's entire career. But as you're about to see, his path to making a real-world impact was, well, anything but a straight line.
In fact, his journey was shaped way more by opportunity and, frankly, necessity than by some kind of rigid, perfectly planned map.
His career path wasn't exactly planned out. He actually went from chemistry to physics and then finally to materials engineering. And each of those pivots, they added this crucial piece to his expertise, but it happened by chance, not by design. But what's really fascinating is that it actually took a professional crisis, a major setback, to really forge his life's mission.
So, get this. He was working in the private sector on a brand new type of laser printer, and his team, they achieved fantastic results. I mean, by any scientific measure, they were incredibly successful.
And here's the kicker. Their work was so good that the owners sold the technology, and the entire team, they all lost their jobs. That one moment became his catalyst. It sparked a brand new mission to help other innovators navigate that tricky path from discovery to production.
So yeah, that experience really solidified his whole purpose, to translate that fundamental science from the lab bench and get it directly onto the factory floor.
He put this mission right into practice with something called nanocomposite metal alloys. We're talking about these incredibly thin coatings, just 40 nanometers thick, that are engineered at the atomic level to create these amazing new properties.
And the challenge? To use this wild nanoscale science to create something that had literally never been done before, a durable, high-performance car mirror made of plastic.
So what was the result? Over 3.5 million of these plastic mirrors were manufactured and put on the Ford F-250 pickup truck. I mean, that is the ultimate proof of taking a lab discovery all the way to the production line.
And all this hands-on experience, it gave Dr. Evans a really powerful vision for how we can improve the entire research landscape.
He pretty much boils it down to three wishes. First, ease up on the obsession with metrics like the H-index and citations. Second, let's build a more inclusive and welcoming research world. And third, and this one's huge, provide funding stability for the people, not just the projects, so they can focus on that big, groundbreaking work.
So ultimately, his entire journey leaves us with this really essential question. It's not just about discovering new things, it's about building the culture and the pathways to bring those discoveries into our everyday lives. So what's it going to take to make sure more of that great science actually leaves the lab?